I'm here with Sitaram Arkalgud from TEL Technologies. Thank you for visiting us. Tell us a little bit about the company, what you guys do, what's your bottom line, what customers you serve.
Thank you very much for doing this. So TEL is Tokyo Electron Limited, and so we supply a lot of equipment to the industry, etch systems, test systems, coater tracks, clean systems, and so on. What I do specifically is in the area of 3DI, so 3D integration. And so we do wafer-to-wafer bonding and a couple of other things like temporary bond and debond. One of the things in the industry is hybrid bonding. It has become very, very popular of late for a lot of different reasons. And hybrid bonding requires extreme control of surfaces. You need to know the surface roughness, and it has to be very clean, obviously. But it also requires very fine control of this copper pad, which bonds. The only thing that can measure all of this is an AFM.
It's an AFM.
Is an AFM.
The alignment there has to be nanometer, sub-nanometer, aligning bonding two wafers?
Aligning bonding two wafers today would be more in the 50 nanometer to 75 nanometer range. Okay. But it's really the roughness, of the dielectric surface. It has to be less than 0.5 nanometers.
You want it to be in contact.
When you want it to be in contact, it has to be really good contact. And so I have no idea what other technique can measure this other than AFM. People try optical techniques. It's not very...
It doesn't work.
It doesn't work. Yeah. You don't have the resolution. And then for the copper pad recess, you need a few nanometers across the 300 millimeter wafer.
Okay, so you want to take the wafer and do what kind of measurements in different places of the wafer?
Yes. Yeah. So what we do would be two types of measurements. One would be, typically 3 by 3 or 5 by 5 micron areas. Of the dielectric. And, because the AFM is not very fast, we measure it in, 10, 15 places across the wafer, maybe more. And then you also look at these copper pads that bond. And for that, you actually go from the dielectric down to the copper pad. And you need to control that recess in CMP processing.
Yeah, and to me it's fascinating that you're able to bond those things with that precision, that alignment.
It's almost like magic.
It's almost like magic, yes. Yeah. So how did you come to know about Park Systems?
So in a previous company, I was doing hybrid bonding development. And so that was where I was very familiar with the NX20.
Okay.
And so when I moved to Tokyo Electron, I wanted, a good AFM. So there was the prior history with the company. And also I do R&D. So it's not high volume manufacturing. And so for that area, we needed something that was semi-automated. If I want to do 25 measurements, I can set it up, walk away, and then come back, right?
Excellent.
So there's no pressure from manufacturing to get the tool back again. Or we can do, as many or as few as possible. We are looking at different modes that the NX20 offers. So 3DI is the main user for this. But, our etch group was very interested in measuring sidewall roughness, and we do some interesting things with the NX20.
Wonderful. I mean, you've seen. It's wonderful to hear about the NX20. I think it's one of our best-selling research instruments. You've seen a little bit of the FX200. What are your first impressions, your first thoughts?
It seems very good. Again, I see a lot of enhancement, especially the way you track the tips. Right, I think that's really good.
Right.
And so reducing error, tip to tip kind of
you have
changes.
Digital notebooks in which you have the sample, the tip that you used, the history of that tip, etc.
Exactly, yeah.
Wonderful.
And upgraded electronics and so on. So I would be very happy to see the 300 millimeter version of it.
Excellent. Wow. Well, thank you so much. It's been wonderful, and thank you for visiting us, for being a user. We really appreciate it.
You're very welcome. Thank you again for all the support that you give us.
Wonderful. Okay. Our pleasure. Thank you.
Thank you. Okay.